Aurora is the name of the supercomputer that Intel is building for the U.S. Department of Energy at the Argonne National Laboratory. It is expected to be the first exascale supercomputer in the US and one of the most powerful in the world. Exascale means that Aurora can perform 1 quintillion, 10 to the power of 18, floating point operations per second. That is about 50 times faster than the current fastest supercomputer, Summit, which can reach 200 petaflops, 10 to the power of 15 flops. Aurora will enable breakthrough science, innovation, and discovery to address some of the world's biggest challenges. Aurora will be based on Intel's next-generation Xeon processor codenamed Sapphire Rapids and its first data center GPU codenamed Ponte Vecchio. Sapphire Rapids will use the Golden Cove microarchitecture and support higher bandwidth MCR DIMM memory. Ponte Vecchio will use the SE high-performance computing architecture and feature over 100 billion transistors. Aurora will also integrate Intel's software innovations such as Distributed Asynchronous Object Storage (DOS) technology, which will provide over 230 petabytes of storage and over 25 terabytes per second of bandwidth. DOS will enable fast and scalable data access for HPC and AI applications. Aurora was originally planned to be launched in 2021, but it was delayed due to Intel's 7nm setback. Intel now expects to deliver Aurora. Aurora will be used for various research projects such as clean fusion energy, cancer treatment, aerospace engineering, neuroscience, and cosmology. Exascale means that the supercomputer can perform at least 1 quintillion, 10 carat 18 carat, floating point operations per second, flops. This is about 50 times faster than the current fastest supercomputer, Fugaku. But what does this mean for science and innovation? Let's take a look at how Intel's Aurora supercomputer outperforms Nvidia and AMD with 10,000 blades. Aurora is a planned supercomputer to be completed. It will be the United States' second exascale computer after the AMD-powered Frontier supercomputer. It is sponsored by the United States Department of Energy, DOE, and designed by Intel and Cray for the Argonne National Laboratory. Aurora will have over 9,000 nodes, with each node being composed of 2 Intel Xeon Max processors, 6 Intel Data Center GPU Max series, and a unified memory architecture which will make a single node have a maximum computing power of 130 teraflops. It will have around 10 petabytes of memory and 230 petabytes of storage. The machine is estimated to consume around 60 megawatts. Aurora will enable breakthrough science, innovation, and discovery to address some of the world's biggest challenges. It will integrate data analytics, artificial intelligence, and simulation for advanced 3D modeling. Some of the planned functions include research on nuclear fusion, low-carbon technologies, subatomic particles, cancer, and cosmology. It will also develop new materials that will be useful for batteries and more efficient solar cells. It will be available to the general scientific community. Aurora will be a game-changer for high-performance computing and artificial intelligence. It will push the boundaries of what is possible and open new horizons for scientific discovery and innovation. Aurora will outperform Nvidia and AMD with its powerful hardware and software innovations from Intel and Cray. Aurora will be the ultimate exascale supercomputer. Aurora is the name of the supercomputer that will be completed in 2023 at the Argonne National Laboratory. It will be one of the first exascale computers in the world, capable of performing more than 2 quintillion calculations per second. That's more than 100 times faster than the current fastest supercomputer. To achieve this incredible performance, Aurora will use Intel's next-generation Xeon processors codenamed Sapphire Rapids and Emerald Rapids, as well as Intel's first data center GPU codenamed Ponte Vecchio. These components will be connected by Intel's One API software framework and a high-speed fabric called Slingshot. The Xeon processors are based on Intel's 10nm process and will feature up to 40 cores each, with support for DDR5 memory and PCIe 5. They will also have advanced features such as Advanced Matrix Extensions, AMX, and Data Streaming Accelerator, DSA, to boost AI and data analytics workloads. The Ponte Vecchio GPUs are based on Intel's 7nm process and will use the SAHPC architecture, which is optimized for high-performance computing. They will have up to 32 GB of high-bandwidth memory, HBM, and support for CXL interconnect, which allows them to communicate directly with the CPUs without going through the PCIe bus. They will also have a scalable design that can be configured in different ways depending on the application. The One API software framework is a unified programming model that simplifies the development and deployment of applications across different architectures, such as CPUs, GPUs, FPGAs, and AI accelerators. It provides a common set of libraries, tools, and languages that can leverage the full potential of each hardware component. The Slingshot Fabric is a low-latency, high-bandwidth network that connects all the nodes of Aurora together. It supports up to 200 Gbps per port and has features such as adaptive routing, congestion control, quality of service, and resiliency. It also supports Ethernet and InfiniBand protocols for compatibility with existing systems. By combining these cutting-edge technologies, Aurora will be able to tackle some of the most challenging scientific problems in fields such as physics, chemistry, biology, astronomy, medicine, and climate change. It will also enable new breakthroughs in artificial intelligence and machine learning, such as natural language processing, computer vision, and reinforcement learning. Aurora is not just a supercomputer, but a superconvergence of HPC and AI that will push the boundaries of human knowledge and innovation. Aurora will enable breakthroughs in various scientific fields, such as fusion energy, cancer research, aerospace engineering, neuroscience, cosmology, and more. It will also support the convergence of high-performance computing, HPC, and artificial intelligence, AI, applications. Aurora is the first exascale supercomputer in the United States. It will be housed at the Argonne National Laboratory and powered by Intel's next-generation technologies. Aurora will deliver over 2 exaflops of peak performance, which is more than a billion calculations per second. Aurora will use Intel's Xeon CPUs, SE GPUs, Optane persistent memory, and DOS storage technology. It will also use Intel's One API software to unify programming across different architectures. Aurora will have more than 10,000 blades, each with 6 GPUs and 2 CPUs. Aurora will also have a fast and scalable network based on HPE Slingshot. Aurora will accelerate the convergence of HPC and AI by enabling researchers to integrate data analytics, machine learning, and simulation for advanced 3D modeling. For example, Aurora will help researchers explore new approaches to contain fusion reactions for clean energy generation. It will also help researchers use deep learning to identify effective cancer treatments and understand the biology of cancer. Aurora will also advance scientific discovery in other domains, such as aerospace engineering, neuroscience, and cosmology. For example, Aurora will help engineers create faster and more complex models and simulations for designing aircraft and rockets. It will also help neuroscientists process exabytes of data to map the human brain and study neurological disorders. And it will help cosmologists perform theoretical research of our universe and its origins. Aurora is the next step to face the challenges we face today and into the future. It will open new frontiers of knowledge and innovation for humanity.